Hey, everybody. Welcome to season 2, episode 2 of the Technological Podcast. I'm your host, Sarin, and I'm joined with my other host, Avi. And we've got guest Tomasz Jurczyk on the episode today. Tomasz is a machine learning engineer here at Moveworks, where I work. Really excited to have him on the podcast. A little bit about his background. He went and studied computer science in Poland for both his bachelor's and his master's degree. Came over to Atlanta and got his PhD in computer science at Emory University. So we got some Atlanta ties. He did a little bit of engineering work at a few other companies, and now he's doing machine learning at Moveworks. So Tomasz, great to have you on the podcast.
Welcome to the Technological Podcast.
Hey, hi everyone. My name is Tomasz, and very nice to be here and share all my knowledge, which I can share with you. Yeah, happy to be here.
Yeah, Tomasz has got a wealth of knowledge, so excited to share with everybody a little bit more about machine learning. We've had some podcasts around data science specifically, and how data scientists work. We've actually had a couple podcasts, so excited to get a machine learning engineer on and talk a little bit about the differences, talk about your day-to-day. But first, let's just start from the very beginning. So, what were you doing before you actually got into machine learning? Before you got into the field of machine learning, what were you doing in the computer science field?
Yeah, so I was psyched about computer science starting early age, probably 7 or 8 year old, and I probably knew already back then that I wanted to go for computer science related stuff. Of course, there wasn't ML at that time; it was too early. But first, I got into when I got into college and grad school in Poland. My specialty was in machine learning. I got into more like a systems specialty, so I was working on more like the distributed systems. I was working on network latencies, measuring like how to efficiently measure latencies in some DSL technologies, etc. So it wasn't my specialty, and that's exactly how I got into my first engineering job, which was as a system administrator. So I was doing more like a systems job, and then I slowly started transitioning where kind of deep learning started picking up the momentum. I started reading on it. Then I got information that from my brother. He also did a PhD in the US. That there's a lot of programs where you can apply for a PhD, and that's how you can actually get more background, more knowledge in this field in machine learning, and that was essentially my start. So it wasn't like kind of a very official way, I guess. It was just first I was into something completely different, but through reading here, there, looking like where world is progressing, where the world is moving into more like an AI type of tools, I started kind of gaining more interest. What is this thing? What this thing ML is, NLP, and all AI related stuff. And then I started seeing how I could grow into this field, how I could actually position myself to enter this field. Yeah.
Got it. That makes a lot of sense. And then as you were really finding your way into this field and thinking about charting your next step in like machine learning, how did you kind of figure out what the role of a machine learning engineer is? And like I'm sure it's definitely changed from when you started to like where you are now, and like the work that you do and like your day-to-day and just like the overall scope of the job. So I'd love to hear kind of like that evolution as well.
Yeah, that's a very good question. So it's like even if you look at the PhD in the field machine learning, which is just one of the fields where you can just get PhD in, even this one field has a lot of subfields. There's a lot of like math theory background of ML. There is also a lot of practical uses of how to actually apply machine learning to solve some problems. So my PhD, what I always like, my kind of background comes from comes from the idea that I love building stuff. I really love building something what people can use or anyone can use. You can visually see what has been built. So I always kind of knew that I would like to apply ML to build some stuff. And it happens to be that that's where ML kind of crosses engineering. So my PhD essentially, I started looking when I came to the grad school in Atlanta. I started looking what kind of real world problems I can try to solve using machine learning. And my PhD was about question answering, about one of the most unsolved and hard one of the hardest problems in NLP and machine learning. And that's where I started building my background. I started looking like what kind of problems there are, what kind of challenges there are which are not specified yet, how to maybe approach them, etc., etc. So my PhD was kind of very unique mix of machine learning, NLP, and information retrieval. It was essentially cross-domain of all those fields. And
do you mind? Sorry, do you mind just kind of like, you said it was like one of the hardest problems, right? So do you mind just kind of like saying what that problem was? I'm just curious to hear. So
question answering is like the umbrella of problems where you search for answer for any type of questions. If you think about like starting like very simple, when did Barack Obama win his first presidential run, right? So there's a one date which you can tie to, and this is like something what you can perhaps very quickly find an answer. But you start kind of traversing to like much more challenging type of problems. For example, if you asked when did Ross marry Rachel, it's kind of from the Friends TV show. The answer is much more convoluted. You have to understand the context. You have to understand the characters. You have to know that this is a TV show. Perhaps the answer is actually in the script, in the script of the show, not actually somewhere on the website. So question answering is essentially, you can define that having any type of question, which usually is represented as a query, find answer, which could be find any context which could be provided as an answer to this. So it's essentially go and find something, and then validate that this is a proper answer, and provide to the user as the context to the question which user had.
Yeah, that's a super interesting problem, because like, to your point, context is so important. And, question answering, like sometimes people can ask very straightforward questions, but, in your point about like, Ross and Rachel, like you have to have a lot of context. And then, when people describe things like their problems, like, I was just trying to figure out how to get my camera to work on this. So I typed in like camera not connecting to QuickTime or something like that, right? Or people sometimes describe their symptoms when their symptom isn't exactly what they're looking for as an answer. And so it's a very interesting problem to work on. And I want to dive a little bit more into question answering a little later, but just thinking more broadly about all the different areas in machine learning. So question answering is like one path, one area of machine learning. What are some other areas? There's computer vision, I've heard, but like, what are some other main problems and domains in machine learning that engineers go into?
Yeah, that's a very good question. So, NLP is one of the domains where ML has provided significant amount of progress in the last 10, 20 years. All those like beefy, GPT-3, all those like bird language models, this is like thanks to ML being applied in NLP. Beyond that, again, as you mentioned, Serene, vision, computer vision, there's a huge progress, right now happening in computer vision. All the advancements which we've seen recently being applied to autonomous driving and image recognition, which is making tremendous impact in medical field. So computer vision is another big one. Computer security. We started actually looking at the computer security of systems from the ML perspective, trying to model behavioral systems. We'll try to essentially like looking what user is doing on a computer, how likely the user is falling into some rabbit hole that like maybe malware or ransomware is actually doing something on a laptop or on a workstation. So computer security is actually right now seeing a lot of hype with ML, where people try to build those systems that predict whether there is a certain risk at the moment happening. So we have to cut out the access to the workstation. There's also many more. There's quant. There is finance, fintech. So I would think like right now in medical field, like pretty much like medical field, of course, has a lot of image recognition, etc. I would say right now ML is like kind of a framework, and it's being applied honestly to all type of problems. Some of these problems we can divide exactly like in domains. Text, vision, these are the main data sources. Soon, of course, people want to map human brain. Maybe sometimes we'll have another domain when we'll build ML systems based on like the signals of neurons in human brains, etc. Right now, it seems like a lot of those domains are positioned around text, around vision, so images, around videos, which in the very root form are the images, and also like numbers. So quant, fintech, and a lot of those fields. Yeah.
Got it. That's interesting. It's essentially like pulling signals, right? And trying to make sense of any signals that you get, filtering out all the bad signals and keeping all the good signals. And, there's like so much more that goes into it that you don't really see, right? People think it's just like, oh, I can just ingest all this data and get an output, but there's a lot that happens in the middle, right?
Exactly.
So,
It often boils down to a very fundamental thing. How do you actually define having something? How you define, like in terms of the system, machine learning, how you define the problem? What is the problem? What do you think as an input? What do you think as an output? For this example of question answering, the input is a user's query. The context is maybe the entire web. Let's say you have the entire access to the entire web, and then the output is the answer. So in many systems, you try to define input output, and you try to build a sometimes black box model, which essentially given input gives you expected output as many times as possible, the correct one. Yeah.
So I have a question about that. I know I don't want to dive like super deep into this, but I am curious to learn more about like how do you kind of think about problem statements for like any problems that you face, like in your job at Moveworks or even like in the past when you were at Yik Yak, like how did you kind of come across and like try and define the problem and then, like this is the problem and this is like what I think maybe the output should be, but like how do you kind of think about, really building that work process out as like a machine learning engineer?
Yeah, that's a very good question. So normally, like when you are presented with some insight, maybe, you don't have a problem yet, but you're looking and you're trying to get inside. Normally we try to think like, is there anything in the research? Is there anything in the books which kind of, resembles this kind of problem? Maybe this kind of insight, maybe we can structure problem, which right now we are trying to kind of structure into a similar problem in the literature. So, we'll try to essentially see whether there's anything in the research, in the previous work, which kind of is close to that, right? So sometimes there is, sometimes there isn't. Sometimes it's kind of like, mix or match. We have to, there are some similarities to specific tasks. So the first even job for in this field is like, how do you really define this as a is there any similarity to the previous work? And if there is, like, how do you actually apply it? Unfortunately, in most of those problems nowadays, if you work on NLP, computer vision, the books, they have formulas. The books, they have like, what kind of algorithms they are. But like, how you modify those algorithms? How do you apply them to make them work on your task? Is the part of problem solving, is the part of this structuring the problem and applying the solution onto your problem. Also, with like what kind of data you have, etc. So it's not always like get the model, apply it on the data in your problem, and you're done. It's actually how you define the problem, exactly like you said, how you actually define like what is the input output, having a clearer, measurable way how you actually execute on it is always essential. You start somewhere, you set up the baseline, and you try to work to how you actually improve the baseline incrementally. It's very rare that you will have something some huge advancements within a short period of time. Normally, it's just a long period of work. We try different things. 9 out of 10 they won't work, but like 1 out of 10 simply it will work, and then you try to drive conclusions. Why you think this method worked but the others didn't? So yeah, there's a lot of mix of the scientific method, of engineering, because you have to set up these processes. It's kind of all blended together where you try to apply the scientific method to solve real world problems. Yeah.
Yeah, that's a great analogy. It's like, that's what a machine learning engineer does, is they're applying scientific method to create a hypothesis, test their hypothesis on, a bunch of data and see whether it produces the right output on what it's predicting is correct or not, and iterating on that and making it better and better. I actually like the way that this is heading right now. Like, let's keep talking about like your day-to-day and roles as a machine learning engineer. Like we can, later on at the end, get to like best ways to become one, and like, how your time was in your PhD, and we can talk a little bit more about that. But, let's take an end-to-end question or an end-to-end problem and figure out, okay, like, can you give us an example problem that you have worked on or are working on? What are the kinds of papers that you looked into? How did you find the data set? How did you train the data set? What did you uncover? How did you iterate on it? Like, can you give us maybe an example of an end-to-end problem you've worked on?
Yeah, that's a very good question. So I'll try to give you like the problem and like how we approach it, like from the very early stage of R&D to like maybe some execution. So what I've been recently working on is trying to essentially. So recently there's been a lot of chatter about knowledge graphs. Knowledge graphs are becoming like the essential form of how you can actually organize, how you can structure knowledge as we know humans around us into a ingestible form which computer systems can actually access, can actually understand. So like in that it's very simple. For example, if you think about knowledge graphs, like people usually think about Google's knowledge graph, where you can have like actors, directors, etc. And for example, this actor played in those movies. Then you go to this movie. This movie was directed by this person, was written by this person. As you can see, it's a mix of objects and relationships between those objects. It's a big network or like interconnected information. And then how those graphs are used in NLP, for example, in question answering, but also in all different sorts of problems, when you can find an answer in a graph, you'll try to do it. Or maybe you will use the graph to kind of, do some feature engineering for some of the different problems you're solving. Okay, so right now we know what the knowledge graph is. My problem, which I recently stumbled upon, was like, we work in the enterprise domain at Moveworks, and how we build knowledge graph, how we actually organize knowledge. First, we started looking like, is there anything what people have tried in this field? You start looking specifically in your field in enterprise, and you also start looking beyond that. You're looking beyond that because you try to see whether there are any similarities. Something what people tried in different domains could actually work in your domain. You try to read, you try to go explore, you go to papers to see how people build a knowledge graph, how people structure ontology, how people approach what is the object, what is the relationship, how people actually approach building the graph, going from having nothing to having something. Like how people actually, whether they approach building the graph from the very supervised way, using a human superpower of like people creating that, or maybe people they created some system which mined the graph for them, having some data sources. They actually extracted objects and relationships from these in an unsupervised way. And then, you look like how we actually apply this graph. We look like how people in different domains applied. And when I'm saying like different domains, because like, sometimes you might find like, oh, your domain is kind of, you couldn't find anything. So then the natural way is like, okay, what people tried for the similar type of problem, but in other domains, in medical field, in entertainment field. Entertainment is very popular for knowledge graphs. There are available graphs like Freebase for like actors, for movies, for TV shows, etc. So the process is like, you think first the kind of there's a light which says like, hold on, maybe knowledge graph would be useful for our problems, for search and enterprise, for example, and then we think about like, okay, so then how we would actually build it and how you would use it. And then that kind of starts with like, being like, how actually approach it, how to, build it. And you start going through the past work, through the research, what people tried in this and different domains, how people applied it, and so on and so on. Yeah.
Got it. That makes a lot of sense. And it's a pretty interesting problem, like, how to build a knowledge graph and then how to actually like use a knowledge graph. So I know before this, Sarin and I were talking about knowledge graphs actually, and kind of like how you were building them out at Moveworks and thinking about like, like the relationships between certain things in the office and, certain areas. Well, one thing I'm really curious about is like, after you kind of built the knowledge graph, what is kind of the next step? Like, what do you kind of use the knowledge graph for? Like, is it kind of like this might be a gap in my like understanding, but is it like used as an index for maybe like some algorithm that you're going to run on, or like, like you said, like search and query, like, you use it to search from, and kind of what are the bigger benefits of having a knowledge graph versus just having like a regular database that you're pulling?
Yeah. What's the alternative to
that?
Yeah, that's a very good question. So, in some of the domains, knowledge graph could give you an answer. Again, when was Michael Jordan born? You can honestly find the date probably in knowledge graph. But unfortunately, world is not as simple as we sometimes think it is, and it's not as straightforward as we think it is. So in many ways, what we actually try to do, we try to use the graph to provide alternative context to something. So I'll give you an example. So when someone says, where can I find information on my HSA? this is a very generic question. Like, I mean, if you ask like a lot of teenagers, they wouldn't know what the word HSA is. You learned it when you start your full-time job, probably, that this is some health savings account. So first of all, like, HSA is a health savings account. But then, it's just what is health savings account? No one knows. It's somehow related to medical coverage, right? This all is talking about something like in HR, probably something in like the employees benefits for employees in within employers. So what knowledge graph does in that case, if you can kind of model those relationships, if you can kind of understand like that there are some concepts which are similar to each other, you can actually start like providing more contexts to different tasks. When someone says something very ambiguous with not a lot of context, because when someone says, again, when was Michael Jackson born? That's a very unique. You have a clear intent of the question. You are asking for a date of when someone was born. You know that this is about person. Michael Jackson, you likely know this is a name. There are systems which will tell you like this is a name. So there is a very clear understanding like what the intent of this question is. But when someone says like information on HSA, that's for a system which is like very generic, like that might be challenging. HSA might stand for many different things. So what you then use the graph for, use the graph to provide additional context, to provide additional concepts close to what the query is talking about, which actually could be instrumental to find an answer in some of the data sources you're working on. Sometimes the sources are very sparse, but sometimes the data sources are very dense. Like, for example, web is something where you can find so much information, but it's like so packed with all other noise that it's really important to filter out what is important, what is good for your type of need, or what is not. So the one thing is like the graph can be essentially the answer, or the graph could provide supplemental information based on to your system. So essentially, your system will use something from the graph to kind of engineer the final solution. It will be kind of a supplemental information. Yeah.
Got it. That makes sense.
Yeah, that's interesting because like also if you think about the space of like Google, for example, Google has tons and tons and tons and tons of resources or websites to scrape and provide an answer. In the enterprise space, it's pretty interesting because each business has their own finite set of resources to look for things. And so if somebody's asking a generic question like what is an HSA, and for maybe some reason they don't have, that business doesn't have a document that specifically says HSA, that does, that's first of all, like just doing that is basic keyword matching or keyword searching. But like actually like by having a knowledge graph to understand, the context of what an HSA is. Oh, it's medical coverage in the HR domain. You can search and pull information and pull resources based off of that context and those things. So yeah, that's super interesting. So, stepping back a little bit, this is all like really, really cool. On just like your day-to-day basis, let's say we're talking to a somebody who's an undergrad who is considering becoming a machine learning engineer or data scientist or a JavaScript developer. What is your day-to-day like? What do you wake up and do? What are your meetings like throughout the week? How do you do what you do every day?
Yeah. So as a machine learning engineer, it's maybe worth to right now mention like what is the reality of machine learning engineer, because like people often kind of see that data science versus machine learning engineering, like which way to go, and like how do I decide? It's actually like there is like some book definition of both, but like what I learned in this field is that companies apply different granularities to those fields. Sometimes machine learning engineer will do a lot of data scientist stuff. Sometimes data scientists will actually do some of the machine engineering stuff. Sometimes they will be like completely separated. So for me as a machine learning engineer at Moveworks, we have pretty much well-defined kind of like almost like a full stack definition of ML engineer. What it means is that, as a machine learning engineer, let's say we'll be attracted by something in a product. Maybe product team will initiate discussion like, oh, we could try to look at that. We could try to look at this. Then we'll try to do a very early R&D, some exploration. What we think about the interesting data, which we could drive some insights from? Can we pull some data sample? Can we find whether people actually ask for this kind of stuff? So there's a lot of kind of like almost like kind of analysis, something what maybe data analysts would actually do, right? So that also is involved in the process. When we finally get into the, the kind of discussion like, oh, this is actually promising. This is something we could go on, right? So then you perhaps start looking like what the data would look like. Can I actually get some reasonable sample to apply some machine learning? That also comes with like, what is the task? What is the challenge? What is the type of problem I'm trying to solve? And again, then you try to, of course, cross this with like, if we can get data, how much data we can get? Is it like thousands of samples? Or is like millions of samples? For a lot of different algorithms, different granularity of data samples will be needed. So that's we kind of start like from a very early R&D exploration. You try to build some POC model. You try to see like, can I solve this problem with 70% accuracy or 90%? Because 70 wouldn't be acceptable. Sometimes 70 is, sometimes it isn't. So you try to work on this early R&D. Then when the early R&D is kind of crystallized, we kind of we have some customers interested about doing something. There is a lot of pull from the market. Then we try to see like we try to pave the way to POC. And what that means is like taking your algorithms and driving them into production. That's what very often is seen as the core bone of the machine learning engineering. You take the model which you or someone else built on local workstation or in dev environment, and you essentially think what kind of processes and what is the process of taking this model and running it in production. On production with all the security constraints, all the type of existential constraints, which in production environment they are. There's just much more challenges. So how do you measure the model? How do you retrain the model? How do you debug the model? How do you basically monitor that there is no degradation and so on and so on? How do you get insights, analytics insights into the model? So you have to think as an ML engineer. You have to think like what kind of pipelines I need for this? What kind of pipeline to pre-process data, to featureize data, to run some tests? What kind of processes on the production when we are deploying the model? Integration tests, startup tests. You try to define how much system requirements you have for the model, how much memory it needs, how much CPU versus GPU. Actually, maybe is it CPU bound or GPU bound model, right? Like all those sorts of things. So essentially the process, usually for a machine learning engineer, the process of taking the model from the prototype form, taking it to production is usually, is usually done by something what we kind of, agreed to call machine learning engineer. And sometimes machine learning engineer will definitely work on the prototype, but in many ways, it will be this just process of productionizing the model and sending into production, where there's a lot of different challenges, other than just purely ML from the ML point of view.
Yeah, there's so much to unpack there, and I wish we could like go into like every single portion of like the stage of like prototyping to thinking about like getting it production ready to actually getting it production ready, and like all the different details that you think about. Like at each stage, it's like almost like you're playing every single type of role, like a developer role to like a product manager type role to like a QA, like test engineer type role, all bundled up into one. And I'm sure like, it comes with a lot of challenges, but a lot of like good parts and like things that you really enjoy. So I'm really curious to like kind of have this question split in two ways. It's like, we'd love to hear, like what are some of the most, I guess, rewarding parts about becoming like a machine learning engineer, and what do you really enjoy about it? But at the same time, like, what are some things like on a day-to-day where you're like, oh, I wish I didn't have to do this again. Or, what am I doing? So.
Yeah, so that's a good question. So it's good to always talk about good and bad things. So, what's really awesome as an machine learning engineer, especially in this like full stack configuration we just talked about, where ML engineer has actually visibility into all of those stages from early on to the last deployment. There's a huge sense of ownership. That's, of course, what our employer Moveworks puts huge focus on, where every single employee at Moveworks have to have a clearer feeling clearer sense of what I'm owning, what I'm responsible for, what other folks can keep me accountable. And I can tell you right now, like, me working on like some ML areas, some ML algorithms, I'm directly responsible for some product areas in our company, which means like, salesperson can come and talk to me and like how we are doing, how this product is doing, and it's going to be directly tied to my work, to machine learning engineering work, right? So that's something what is super cool. That's something what probably I would miss from a typical machine learning like scientist role, where like you're working on hard problems, very hard problems. You have an input, you have an output, and you try to find any way. Some people really enjoy that, working in those very structured environments. What I enjoy as a machine learning engineer is like being in those like heavily unstructured environments where I have to like go define the area and then push in this area to to become the owner, to essentially to make that others see me responsible for pushing the solution in this area forward. So that's the most favorite thing, kind of the clearer sense of ownership and responsibility that people actually hold onto you. The least part, which I like the least, and sometimes it's kind of like big pain, is the lack of data. So that's something what kind of can get you in the really bad and sad place when you see an exciting promise from product team. Let's do this, let's do that. And you kind of create like visions in your brain, like, oh, I'm going to use this model, that model, I'm going to set it like that, and then you kind of suddenly you're being smacked with like the reality of like there's no data. So you have to probably build some heuristic first to maybe roll it out as heuristic and collect data. So sometimes it's kind of very sad place where you're getting into that. You have to think really, really in a fundamental way, like how to do something out of nothing. And that's something, that's something what not everyone is looking. And I think majority of people wouldn't enjoy doing. It's like, you normally, you think of like, I could go there and grab this data. But often it's just, if something was never productionized or something, you have really no data. So you have to maybe find like how you would do something out of nothing through some heuristics, through some early choices, like collect data, then maybe approach it from that, right? So sometimes, again, those processes like which we follow, they don't go according to the normal cycle as we know them from PhD as I know them, right? In PhD, like we normally think that there are some data sets, there are some kind of points where we can go out and grab some insights from the data because the data is usually available. But in product, in the enterprise world, in the corporate world, the reality is brutal. Like very, very often we don't have this data, and that that sometimes gets you into this like place where you're being you're getting maybe some anxiety. I heard like people like, that's not what I imagined doing actually as a machine learning engineer. Like this is a reality. Like that's what they told me I'm going to be doing, and that's what I'm doing. Like what is this, right? But that's you have to find a way how to deal with it. You have to find a way. That's also the part of the learning in this career path, that you have to actually be very comfortable in those stressing, uncomfortable situations where they ask you to do something out of nothing. You have to try to come up with like some solution, like how we start with this, with simple heuristic, like we use it to kind of roll it out as a pilot, like collect data, and so on and so on. That's also I would say the part of the learning in this process, as a being machine learning engineer for for folks who are early in this career path. That sometimes is like something what will define their fundamental, like how successful an engineer they will be in this career. Yeah.
Got it.
Yeah. That's great. That's great. So let's say that some people in our audience are really cool with having all the impact in the world and productionizing a model, and they're okay with lack of data, and they decide, okay, I want to get into becoming a machine learning engineer. Like they want to roll up their sleeves and figure things out and become an engineer. In your mind, number one, I guess it's a two-part question. How did you get to the place that you're at today? What would you, attribute, a lot of your success to get here? And then also, what's your best advice to give somebody who wants to get into this field?
Mm-hmm. Yeah, that's a very, very good question. And I'm going to exactly say how I got into and what I think is a good way to get here. So again, machine learning engineering has one third of it is like engineering. So there is a huge part of engineering inside machine learning. So it's a really unique field where you have to have basic concepts, fundamentals in machine learning. Maybe you're not like scientist, you're not like, you don't know like exactly how to turn all the knobs in the model, but like enough to maybe to know the fundamentals in machine learning and some of the fields you're trying to step into. Like machine learning engineering is like a unique blend of machine learning and engineering. So how I got into this was through, in my case, it was thanks to being exposed to machine learning through my PhD. It could have been masters, it could have been bachelors. In our lab at Emory, we had a lot of bachelors and a lot of masters who were actually doing projects with PhDs. Some research projects, but also some of those were like heavily on engineering. And that's how those undergrads and masters were getting actually exposure to machine learning. Then if you want to step into this road, you have to have strong engineering fundamentals. What I'm thinking is like, how to, in the recent, in the recent times, like, there's a huge hype about Kubernetes, how to basically deploy machine learning scalable way using Kubernetes, right? So you have to have fundamentals like what is Docker container? You have to know those things. You have to know those system fundamentals. You don't have to be an infra engineer. You don't have to know from the principles of those, but you have to know how they work more or less, and how you can use those to get your stuff in. So thanks to me, thanks to the PhD in my case, because I was exposed to it, and I had a pretty decent background in engineering because I've had jobs before, like systems admin or software engineer. I could like pretty much like find this connection really easily. So the best path I think for college students or for master students is like try to get involved with some of the NLP, computer vision, maybe network security labs in your college, in your grad school, and try to approach those professors. They will often have projects where you can work on this and that. Sometimes you can actually even be a part of the research work, which will make you end up being one of the authors in the research paper in one of the most respectable conferences. That's the immediate workshop, how we build this muscle of navigating through the machine learning world. That's for the ML part. For the engineering part, of course, try to of course take as many classes as possible. Is the best if your major is CS. Try to do internships. For sure, it's the internships are essential. I would say at least 1 or 2 internships in your four-year college history should definitely be there, because internships, when you kind of take what you see is like the academic side of the computer science, and when you enter the industry world, it's kind of it's very different. But it's kind of good to have this early exposure to this, and that's how you start building your network. You start meeting people, and which later could kind of give you very fruitful outcomes, right? So that's I think are 2 essentials. 1, try to find a good channel entrance to ML through maybe the labs in your college, professors, any people who could pull you in, and you could get close to folks who are working in this area. And the second, try to get good engineering workshop through taking classes in systems and computer science and through internships. And then, of course, once you're looking for a job, that's also is tricky because right now some employees will actually list machine learning engineers as data scientists. So the best, honestly, is if you have someone who knows someone who works in this company, you can try to get some, some R&D, hey, what are ML teams and machine learning engineers doing in this company? Is it more like a data science stuff, or is it more like ML stuff, right? So you can try to measure, you can try to kind of measure the market, which companies you think are good approaching for if you want to grow into this role. So yeah, these are kind of my thoughts. It's kind of you in the data science world, you really don't have to pay that much of an attention to engineering. I know that some people will disagree with me, but honestly, a lot of data scientists just live in their Jupyter notebooks world, and they don't really stretch themselves out of that. But in machine learning engineering, you have to be much more comfortable with systems aspects, in language aspects, in productionizing stuff, essentially making stuff available to other systems in the cloud, for example, if you're building cloud products. So these are my thoughts. What is the right way? What is the best way to get into machine learning engineering? Yeah.
Mm-hmm. No, definitely. That's great advice, and it's interesting to hear. Actually, our last episode was with the data scientist. So it's interesting to hear like, the difference between how she thought about, getting into data science and how you think about getting into machine learning. And yes, there's some like similarities, but there's also like a lot of differences. And it's cool to hear that firsthand. So like, I think like one question, and like this, like we're coming close to the end, but one thing we really want to hear about more is like, where do you see your career as like a machine learning engineer really heading? And how do you kind of see that evolving with, the overall field itself? And like, how can you really position yourself to make sure that you kind of grow as the field grows?
Mm-hmm. Yeah, very good question. So, recently I've started like taking more tasks, more like challenges, like more like a tech lead, and the kind of senior engineers, where I try to kind of overcome things like how kind of long-term growth of products which are using machine learning. So for example, in my early career, what I developed is like I was working on like problems, like still defining problems, like solving them, trying to always kind of approach it like, can I do it? Yes, I can do it. Today I'm thinking more, can we do it? Yes, we can do it. Like, as a team. And so essentially right now I started like what I would like to my career go is to go more into this like cross of the management and like the tech lead position, where maybe not directly getting into the management people position, but like the management of the projects. So like director of engineering, like those kind of areas where you can kind of think like how the find dependencies between teams. Is there anything we can actually use between each other? Like how to essentially be a kind of a mind, how to build the kind of a long-term vision into your machine learning engineering culture in your company, right? So thinking like how to make machine learning folks efficient, so there is no repetitive work, that there are good blend of folks working on those problems, like good diverse set of folks from platform, from core infra, etc. So I want to start also helping on coaching younger machine learning engineering, like how they can essentially quickly grow into the roles, because like there are some very interesting steps which you can take to kind of make immediate impact and like show yourself from the very best angle. Sometimes people need a little bit push. Sometimes this will grow naturally out of them, but sometimes someone has to tell this to people. Sometimes it's not obvious. Coming from the college background, where you just go to classes, you attend classes, do homework, etc. Like in the company. If you don't do it, like no one else is not going to do it. So you have to just step in as with initiative, and so sometimes you have to give people a little bit of guidance, and they will just grow very quickly into this role. So I want to be also part of like how I can help younger engineers, to really quickly grow, show impact, and immediately show their value to the team, to the company, how they can deliver immediate value to the product. Yeah.
Awesome. Well, it's always great chatting with you, Tomasz. Like I feel like time just flies every single time we talk.
Yeah,
awesome.
Definitely. It was great to chat. Great, tell you what I think about the right way. Again, it's just I feel like the world is changing so fast in machine learning, data science, and all AI kind of sort of like umbrella of tools. We could have a chat like 2 months from now, and we probably would have like all sorts of different new ideas or insights we could have. So it was very exciting to be here and share all the thoughts with you guys.
Yeah, definitely. We'll probably have to follow up with a part 2 coming up soon.
Yeah, I want to dive into some of like, I know we can't really do that on this podcast, but some of the technicalities of like the question search, because like I'm really interested to hear like like people ask like billions of variations of questions. Like Sarin might ask like, how do I set this camera up a certain way, and I might ask it a different way, and like how do you pull like each keyword to figure out like what the question actually is, and like like is it like you were talking about, is it a name, or like what type of question it is? I'm really curious to learn more about that, because I took like a knowledge-based AI class back in college. I was a computer science major, and we did a lot of like work on like figuring out like how to build like you were saying, knowledge graphs for like NLP, and figuring out like how to extract words and then match them up, and like look, is it a verb, is it a noun, like what could they be asking, like what could the action be? So yeah, that's super interesting stuff.
Yeah, awesome.
Yeah, happy to chat. Yeah, definitely.
Yeah.
listeners, get ready for part 2 soon. We're excited that we finally got Tomasz on. And if you guys have any questions, feel free to reach out. We'll provide Tomasz's contact info and LinkedIn in the description. Always reach out to us via email if you have any questions about the podcast as well. And thanks so much for tuning in. We'll catch you next episode.
Cool. Thanks, guys.